All right, guys, so settle in here. We're going to work our way through this geometry review together so that you guys can have a great way to check your answers, see if what you're doing is correct, and make sure you're on track. So, jumping into the beginning one. This one says, any triangle may be rotated and translated so that one vertex is the origin and another vertex is on the positive x-axis. What is the relationship between the length of segment DE on one of the triangle's midlines and the length of BC? Well, this one's pretty easy. If you know exactly what that triangle midsegment theorem is, this problem ends up being super simple. So the triangle midsegment theorem says two things. The first thing it says is that this line segment right here that we call the midsegment, because it's in the middle of AB and the middle of AC, that midsegment has to be parallel to the one side it's not intersecting. So it's going to be parallel to this side. So that's one thing we know, but looking at our answer choices, it doesn't say that. So really that doesn't help us. But it does tell us another thing. We know that the midsegment has to be exactly half the length of the line it's parallel to. So in this case, DE has to be half the length of BC. So we could look for a statement that says that DE is half of BC. I said AC because that's the first answer, but it's not half of AC, it's half of BC. So this one's not going to be good. If this was adjusted to a B, we'd be good, but I don't see that on here, but I do see it right here. DE is half of BC, so that's the answer choice we want, to say that line segment DE is exactly half of line segment BC. All right, coming on up here, the next one. Find the length of HI. So this one right here is the segment addition postulate. Thinking back to when we did the segment addition postulate, it's not too hard either. It's just that if you take two smaller segments that are adjacent to each other and add them together, it has to equal the length of the whole big segment. So we're going to add these two pieces. So I'm going to put 2x plus 10 on top, and right underneath it, I'm going to put 3x plus 7. These are both these pieces right here that are coming from the two sections, the first half and the second half. So if I add 2x and 3x together, I get 5x. 7 and 10 gives me 17. And once I get that piece, I'm going to set it equal to the length of the whole thing, which is that 8x plus 5 part. So we're going to set 5x plus 17 equal to 8x plus 5. When I'm doing my algebra, I like to always get rid of my my smallest variable first. So in this case, I'm going to get rid of the 5x first. That's going to cancel. I bring down my 17. 8x minus 5x is going to give me 3x. Let's bring down this positive 5. And now we're just going to solve this like we'd normally do. I'm going to subtract the 5 from both sides to get that x by itself. I end up getting 12 is equal to 3x. And that last step, divide by 3. I'm running out of space here, so we'll come right over here. So when I cancel out over here, I'm left with an x, and 12 divided by 3 is going to be 4. And so I get x equals 4. But if I circled that answer and was done, I would be wrong, because you always want to make sure. Every single test problem, go back and check the directions. Find the length of HI. Well, now that I know x is 4, HI is this line segment right here. So we just need to plug it in. If I plug in 4, it's 2x plus 10. So 2x is 4, so we'll put 4 plus 10. Well, 2 times 4 is going to give me 8. 8 plus 10 is going to give me 18. So it looks like I'm going to choose answer choice B. Make sure to pause it if I'm going too fast so you can get what you need. I'm going to keep going so that I don't take forever because I don't want to stay after school this late. All right, over here it says, if angle AEB is 2x plus 32, immediately before I go anywhere, I'm going to write that in here. AEB is this angle right here. Remember, you focus on the middle letter because that's the vertex. So here's E going out towards A and going out towards B. So this angle right here is 2x plus 32. I'm going to write it right in there. And angle DEC, again, we're going to focus on E, but this time we're going to go out towards D and out towards C. So it's going to be this bottom angle is 1/2 x plus 65. Well, something I instantly notice is those are vertical angles. And vertical angles have to be equal to each other. So this problem is really simple. We're just going to set the two equations equal to each other because they're vertical. So 2x plus 32 equals 1/2 x plus 65. And I already see the problem. Which one's the smallest variable? Well, the smallest variable is half of x. And that's going to be weird, but I'm going to do a quick change right now. In my calculator, if I do 1 divided by 2, I'd get 0.5. So I'm going to subtract 0.5x instead. And then 1/2 and 0.5x are going to cancel. And that makes it easier over here. 2x minus 0.5x is going to be 1.5x. So again, I know this is 0.5x because all I did was take 1 and divide it by 2, and you get 0.5. 1 divided by 2, 0.5. So I bring down my positive 32. This canceled, I bring down my 65. So I'll subtract 32 from both sides. I end up with 1.5x equals 33. And let's see, 33 divided by 1.5. So we divide by 1.5 over here, divide by 1.5 over here. That cancels. And I get x equals 22. Double check, did this problem say just find the value of x? It sure did. So I'm good. 22 is a valid answer. We're going to pick C. All right, question number 4. If line R and S are parallel to each other, then all the following statements are valid conclusions except, and what I noticed is that all these statements are congruent statements. So what I'm going to do to make this super easy, we're trying to find the one that's not a good conclusion, so we're going to put in this problem, ABBA, 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 ABBA. And if you recall, all the A's have to be equal to each other and all the B's have to be equal to each other. So the first one says 3 and 7 are congruent. Angle 3 is congruent to angle C. Well, angle 3 has an A and angle 7 has an A. So that seems valid. So I'm going to check it off. That's a good conclusion. Remember, we're looking for the one that's except the wrong one. Angle 1 is an A, is congruent to angle 5, an A. They're both A, so that's valid. Letter C, angle 1 and angle 7. Well, 1 is an A and 7 is an A, so again, that's valid. So this must be the one. 3 and 6, angle 3 is an A, angle 6 is a B. That is our invalid question because 1 is A and 1 is B, so this is the one that is not a valid conclusion. Number 5 on here. Point A has the coordinates 2, 5, and point B has the coordinates 6, 17. How long is segment AB in simplified radical form? So you can use the distance formula for this. So for those of you that like the formula, distance equals x2 minus x1 squared plus y2 minus y1 squared. Once you get all that, you square root the whole thing. I hate that formula. I hate it. I don't use it. Here's what I'm going to use instead. I'm going to put these points one on top of each other. So I'm going to put 2, 5 on top, and directly underneath it, I'm going to put 6, 17. And what I'm going to do is I'm going to find the difference between 2, 5 and 6, 17. And with that difference, I'm just going to plug it into the Pythagorean theorem. So if I'm finding the difference, I'm going to change the signs on the bottom point to make them subtraction. So this is going to become a negative 6 and a negative 17. So 2 minus 6, negative 4. 5 minus 17 is negative 12. And those two numbers are going to be respectively A and B in the Pythagorean theorem. A squared plus B squared equals C squared. What's nice is when we plug in here, I don't really have to think about the negatives because negative 4 squared is going to be negative times a negative, which is positive. So negative 4 squared and positive 4 squared are the same thing. So really when I plug in here, I drop the negatives. So I'm going to make this just 4 squared plus 12 squared equals C squared. So 4 squared is going to be 16. 12 squared is 144. And if I add that together, 144 and 16, I'm going to get, let's see, 160 equals C squared. And so my last step is just to square root out this to get the C is equal to 160 square rooted. Now it did say put it in radical form, and that can be a little bit hard to remember. Essentially, we're looking for two things that multiply to make 160, where one of them is a perfect square. Some of you might be like, Mr. Knock, I don't know how to do that. Well, here's a good trick you could use. You could take the square root of 160, which is 12.649, and then you could just try all these answers out. Well, obviously 160 and 48 do not equal 12.649, so I can cross A and B out. We know it has to be one of these two, and all these two state is take the square root of 10, multiply it by 16. Take the square root of 10, multiply it by 4. We just need to figure out which one's going to be 12.649, and that's pretty easy because if you take the square root of 10, you're going to get 3 point something, and 3 point something times 16 is definitely not 12. It's going to be bigger than 16, and 12 is less than 16. So this one's going to be your valid answer. For those of you that do want to understand radicals a little bit more, all we're doing is saying what two numbers multiply to make 160 where one of them is a perfect square. And what I come up with is that the square root of 16 and the square root of 10, well, 16 times 10 is 160. The square root of 10 is going to stay because it doesn't square root, but 16, the square root of 16 is 4. So we get 4 radical 10, 4 radical 10. All right, number 6. Number 6 should be a super easy question. This is going to be on your exam, I promise. What are the undefined terms? Oh my gosh, this should be one of the easiest questions. You should not miss it. Remember this. You're going to write down, remember your PLPs, your points, your lines, your planes, your PLPs, or your people. If you want to remember it, don't forget your people. PPL. So points, planes, lines, those are the three that start with PPL. So it looks like I'm going to need the one that has 1, 4, and 5 on it. 1, 4, and 5 looks like answer C has 1, 4, and 5 Roman numerals. Please, please, please make that acronym something you remember. You will need to know your PLPs. Next statement. Next question, number 7. Marcy made the following statement. If two lines are parallel, then they have the same slope. Which of the following is a correct analysis of her statement? Well, we have to decide. Two parallel lines, do they have the same slope? And we have to decide if Marcy is true or not. Well, let's think back to when we did this. Did we say parallel lines have the same slope? We did. And we also talked about perpendicular lines, and they have opposite reciprocal slopes. So parallel lines do have the same slope, so we know her statement is true. So we could definitely cancel out B, which says her statement's false. And we can cancel out D that says her statement is false. So we need to decide, is her statement always true or is it sometimes true? This should be a no-brainer. We know that's always true. Parallel lines always have the same slopes. That's essential to being parallel. So we're going to pick A. Always true. Number 8 says, find the contrapositive to the following statement. If Jack plays baseball, then Jack participates in sports. And that's where I did that hand trick with you guys. I held out my hands. I said, this is if P, then Q. And then we switch it. If Q, then P. And then we go back and we close our hands and negate it. If not P, then not Q. And then we switch it again. Not Q, not P. So in here, I used what we called the Seasick Chart. Don't get seasick. C was for conditional. And then you have two converse shoes, so it's the second one. I is for inverse. And the last C is the long one, contra positive. I'm going to shortcut it and put a positive there. So it looks like we're trying to get to this last one, which means that we're going to switch it, go back and negate it, and then negate and switch it. So it's both of them. So if Jack plays baseball, needs to move to the end. And Jack participates in sports means to move to first, but they need to be the opposite. So the opposite of Jack participates in sports is Jack does not participate in sports. And that looks like there's only one possible answer. D. Jack does not participate in sports. Let's make sure it fits, though. It should say, then Jack does not play baseball. Then Jack does not play baseball. That's perfect. D is it. D switched them and made them the opposite. Number 9, Raymond threw a ball that bounced up at an angle of 2x plus 4. What is the value of x? Well, look at that. They already put everything in this picture for us. What do you notice about this angle? Oh, that little box. And that little box means that this angle is 90 degrees. So this is just an angle addition postulate question. If two angles are adjacent to each other, you can add them up and set them equal to the larger angle on the outside. And that's exactly what we'll do here. 3x plus 6, add it to 2x plus 4. So my 3x and 2x makes 5x, 6 and 4 makes 10. And then I'm going to take that equation and set it equal to the whole thing. And the whole thing we already decided was 90. Okay, here's my my thing that we're going to solve. I'm going to draw a line through my equal sign. So I'll get rid of the thing after the x, that side piece. 10 minus 10 is going to give me canceled out 0, so we just have 5x left. 90 minus 10 is 80. And then we'll divide by 5, and I get x equals 16? Yeah, 16. Sorry, I had a little moment there. X equals 16. Double check, is that what it asked for? Yes, find the value of x. We found the value of x is 16, so we can pick answer A as our valid choice and be correct. Number 10 comes back to those parallel lines with the transversal, so you might want to use your ABBA trick again. So starting up top, A, B, A, B, B, A, A, B, A, B, B, A. So this question said that they're parallel and they want us to, not find x, they find the value of ABC, so we'll come back to that at the end. The equation 10x plus 30 has an A on it, and the equation 5x plus 5 has an A on it. Since they're both A's, they're equal. Remember, if one was an A and one was a B, that would mean they're supplementary, so we add them up and set them equal to 180. But if they're the same letter, we just set them equal to each other. So 10x minus 30 is equal to 5x plus 5. And we're going to solve that. So I always get rid of the smallest variable first, so I have 10x or 5x. 5x is my smaller one, so I'll cancel the 5x out. That way it stays positive. So 10x minus 5x is going to give me another 5x. Bring down that minus 30. Bring down our positive 5. So now I have 5x minus 30 equals 5. So I'll add 30, add 30. So my 30's cancel and I get 5x equals 35. And then I'll divide by 5 on both sides. and get x equals 7. So again, I told you if you rushed into this, sorry, I'm off my screen a little bit. If you rushed into this and picked x equals 7, you'd get the wrong answer because this didn't say find the value of x. It said find the measure of angle ABC. So we need to find ABC. Here's A, here's B, and here's C. So it looks like the angle in between those two is this angle right here, which happens to be a B angle. So if we figure out what the A is, we can figure out what the B is easy because they have to be supplementary. So I'm going to take 7 and plug it in right here to this 10x minus 30. So 10 times 7 is 70, and 70 minus 30 is 40. And if that angle A is 40, then all the B's have to be what number? Well, they have to add up to 180, so we're just going to take 180, subtract the 40, and we find out that all the B's have to be 140. So my answer is C, 140. All right, going on to question 11. 11 says, which graph best represents the line parallel to the line with the equation y equals negative 3x minus 2? What's super nice about these questions, if they ask about parallel or perpendicular, we only care about one number in this whole equation, and that's the slope. And slope should be the number that goes in front or precedes the x. So in this case, the slope is negative 3. So I need a line from this graph. We're looking for one that has a slope that's the same. We need a line that has a slope of negative 3. So anything that's going down is a negative slope. So see how this is trending upwards? This definitely isn't the answer because it's positive. Same thing with this answer down here, answer C. It's positive. We know it has to be one of these negative slopes, either B that's going downwards or C that's going downwards. So let's start with answer B. If it has a slope of negative 3, we want to turn that into a fraction. So my slope is really going to be negative 3 over 1 because we want it as a slope. So it should go down 3 over 1. Let's check out B. Down 1, 2, 3 over 1. Wow, look at that. That's it. It's definitely going to be B. If you look at answer choice D, you can see that instead of it going down 3 over 1, it goes down 1 over 3. So they tried to trick you. This one's down 1 over 3. So this is the slope is negative 1/3. So B is the slope we want. 12 is a bit of a doozy, but in a multiple choice question, it's super easy. A line passes through the point 6, negative 3 with a slope of 2/3. Write the equation of a line in slope-intercept form. Well, if the slope is 2/3, we already can eliminate two answers because A has a slope of negative 2/3 and B has a slope of negative 2/3. And that's not what we want. We want a slope of positive 2/3. So it has to be C or D. And this is why these questions are so easy. That's the X and that's the Y. Plug that in for X. If you get this for Y, it's correct. So Y equals 2/3 X. So we're going to plug in 6. And then we either have plus 7 or minus 7. We got to figure out if we want to add 7 or subtract 7. So I'm going to put both up there. Which one will give us negative 3 as an answer? So, why is that so blurry up there? Never mind, it's just the angle I'm looking at it, sorry. All right, so 2/3 times 6. Remember when you have a fraction times a whole number, you multiply on top and then divide by whatever's on the bottom. So 6 times 2 is 12, and 12 divided by 3 is 4. So we can either do 4 plus 7 or 4 minus 7. We just need to get negative 3 as an answer. And I think that we all can see plus 7 is going to give me a big number that's not anywhere near a negative number. It's definitely going to be that subtraction because 4 minus 7 is negative 3. Negative 3 is what I wanted, so D is the right choice. 13 says PQRS is translated 6 units to the right and 4 units up. What are the new coordinates? These are easy. 6 units to the right means count right 6 units, and then 4 units up means count up 4 units. So I'm going to start it. Let's start at Q. It says go right 6 units. So 1, 2, 3, 4, 5, 6, and then go up 4 units. 1, 2, 3, 4. So it looks like I'm currently at the point positive 3, positive 1. And that was for Q. Maybe we could just look right now. Do any of these Q's have positive 3, positive 1? Wow, only one of them does, and it's C. Look at that, you're done. You could double check every single one of the points and check that they're okay. But just within one point, I can already see that has to be the right answer. Number 14 says classify the triangle with the vertices at the following coordinates. This one is a doozy because we got to do the distance formula 3 times to figure out. We need to find the distance from R to S. We need to find the distance from S to T. And we got to find the distance from T back to R. So being good at your distance formulas helps here. RS, R is at negative 2, negative 2. S is at 1, 4. Remember, I don't really use that distance formula. I put 1 point on top, 1 point on the bottom. And that point on the bottom, I switch to the opposite signs. Anything that's positive becomes negative. Anything that's negative becomes positive. And I add -2 and -1 is -3. -2 and -4 is -6. And then I'm going to plug into the Pythagorean theorem. 3 squared plus 6 squared is equal to c squared. So I end up with 9 plus 36 equals c squared. And I get 45 equals c squared. And we'll put a square root over both of them. And we're going to hold it right there. I don't really care what the decimal is. This is enough information. We're going to next do s to t. So put 1 and 4 on top for s. And underneath it, we'll put t as 4 and -5. But we're going to switch it. 4 becomes -4. -5 becomes +5. And then we'll add -4 and 1 is -3. 4 and 5 is 9. And we'll square those two things and add them together to get c squared. So -3 squared is 9. 9 squared is 81. And I'm going to add that up and get 90 equals c squared and square root it. Last, we got t to r. T is at 4, -5. R is at -2, -2. We're going to take that -2, switch to +2. Take that -2, switch to +2. And I end up with 6 and -3. Hey, I've seen 6 and 3 before, right? In that very first problem, we did 6 and 3. I already know 6 squared is going to give me 36 and 3 squared is going to give me 9. So I'm going to get the same answer. So let's just shortcut it. Let's just put that 45 there and be done with it and not do the work. So here you can see 1 and 2 sides are equal. The first and the third one are both square root of 45, and one side's different. So what kind of triangle has 2 equal sides? Well, we know that's the isosceles triangle, because there's 2 s's in isosceles. Number 15 is going to be a dreaded proof, our favorite things to do ever. The following proof has 3 missing statements. They gave us this, and they said, what are the missing statements that have to go into this proof? It's weird. They did this proof, and you can see that their right side, instead of doing a left and a right, they did a left as a statement, and then their reasons are just in parentheses. Don't know why, that's kind of weird, but we're going to go with it. And they told us 3 statements. We just got to put it in order. Well, one of the things that stands out to me really easily in this problem is just focusing on the statements. Even if you have no idea how to put this proof together, we know that corresponding parts of congruent triangles, or CPCTC, has to be the last thing. Like, it just has to. You can't put CPCTC in the middle of the proof. So we know this is the third thing, so T has to be last, which means it can't be statement C because S is last, and it can't be statement A because R is last. So it has to be either B or D because T is last. Then we look here. Well, would you say angle side angle first, or would you say alternate interior angles first? Well, if you paid any attention to this, you know that alternate interior has to go first because ASA is one of the last things. Like, if we're doing this proof, ASA or SSS or SAS or AAS, those always go almost to the last unless there's CPCTC. So to me, I think that has to be second, and we recognize that alternate interior has to go first because we have to prove the angles are congruent first, then we can use ASA. So I'm going to look for SRT. SRT is statement D. All right, number 16. 16, to show that BDE is congruent to CTO. That's this big triangle here and this big triangle here that are overlapping to make this little guy in the middle, which might be a little confusing. Using corresponding parts of congruent triangles, which of the following would you need to prove? Using corresponding parts of congruent triangles are congruent, which of the following would you need to prove? COT, hold on one sec. To show that they are congruent using corresponding parts of congruent triangles are congruent, what would you need to prove? Oh, wow, I had a moment. If we want to show anything is congruent by CPCTC, what has to go before it? We talked about this. CPCTC just has to go last. So before you can say CPCTC, you gotta say that the triangles are congruent. This should be easy. We always do triangles congruent to triangle, followed by CPCTC. So D has to be the first thing. I am.